Okay, I have found a couple other videos that I'm going to let other people explain standing waves to you a little bit, but I just kind of want to just mention a couple things. So standing waves are when you have two periodic waves, same frequency, same amplitude, but moving in opposite directions. They will interfere with each other and they will form a resultant wave that we call a standing wave. So it looks like it's basically looks like it's standing. It's not really moving at all. And if you look in this little animation here, you see a green wave that's moving to the right. You see a blue wave that's moving to the left. And so they're going to interfere with each other, and you wouldn't see either of those waves. You would just see the resultant standing red wave. So you can see when the green and the blue wave, two crests, line up, then they constructively interfere and they make a really big, tall red wave. And then when the blue trough and a green trough line up, they make a really big red trough. And so it's just basically a trough and a crest that kind of just oscillate back and forth. And you'll notice that there's points all the way along this red standing wave that are called nodes. They're not moving at all. So the upwards displacement and downwards displacement of the big crest troughs, those are called antinodes. I call them loops. I generally call them loops. But then all the way across the middle, you have these points that are called nodes that are not actually moving at all. So if I kind of freeze it here, you'll see the green wave and the blue wave are about to hit, and so they're going to be constructively interfering, and this red wave here is growing up. And so there's a peak right here, and there's a peak here, and so on. But you'll notice, and this is gonna eventually move all the way back down, and this one here is gonna move back up. So they're gonna be kind of going. So then it'll look like this, and then this one will look like this, right? And I can actually kind of fill it in like this, right? Okay. So there's these places here, all along here, that don't ever actually move at all. I could actually hold on to one of those places. Those are called nodes. All of those places right there are called nodes. But these big places here in the middle are called, that are going to go up and down and up and down and up and down. Those are called loops. Those are called loops or antinodes. So one thing I want to try to point out here, I'm going to kind of erase that and let that go again. One thing I want to point out here is that if this was going really, really fast, so like waterways, if you bounce water off of a barrier and they come back on themselves, the waves come back on themselves, they'll eventually form these standing waves. And they're really oscillating up and down really, 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 really quickly. So if they were doing that so quickly that you would see that you have a crest right here, and these crests kind of act like lenses. And if you've ever seen in the bottom of a pool, you see all these little white squiggly lines, on the bottom of the pool. Those are basically, any little white line you see is actually underneath a crest. The crest kind of acts as a lens to focus the light, and it would make like a white line down below here. Of course, under this one here, you'd see another white line, and under this one here, you'd see another white line on the pool. Okay. Now the problem is, and if I measure from one of these to one of these, I would have one wavelength, right? Because this is a crest, and then it goes down to a trough, and then to another crest. Okay. The problem is that these are moving so quickly that this trough here is going to move up, right, to be a crest, and this crest here is going to move down to be a trough. Okay. So at the very next fraction of a second, this will be a crest, and all of a sudden you'll see a line right here. Now when you see this line, these two lines actually would turn off. This one here and this one here would actually turn off. But this one would turn on. This one's going to go up to a crest at the same time this one is, and you see another line right here. So the problem is like on a test or on some kind of drawing, you might see a whole bunch of lines like this. And if I tell you that these lines are the result of a standing wave, then what your eye is going to deceive you, because if you see this line would be on, and this would be on, and this one would be on, but these in the middle here would actually be off. But it's happening so quickly your retina can't distinguish it, and you'd see all these lines basically all at the same time. Does that make sense? I hope that makes sense. Okay, so if I said, hey, how long is a wavelength? You might be tempted to say from here to here, because that's the crest to a crest, right? But that's not what's happening in a standing wave. It's actually from one of these to the next one. That would be one entire wavelength. So don't get tricked. You need to know that if I draw a pattern like this on there, you're going to want to know, is that just traveling waves? If it is, then one wavelength is between two of those lines. But if I say this is actually a standing wave pattern here, then you need to actually measure between two lines to tell me how far a wavelength is. Okay, so I'm going to let the other videos kind of explain more about standing waves, and hopefully that'll make sense.